Hey there, this is me Kanita Rahman and you are on my channel Content Factory. Today we are going to discuss about a topic from linear algebra, that is system of linear equations. But first of all, recall some of the major concepts related to it. But before this, click the subscribe button below to get my latest videos on time. It's absolutely free. Come back to my topic. Let's see the word system of linear equations. First of all, let's discuss what is equation. But before equation, you have to know what is expression. Combination of at least two numbers and one mathematical operator. There should be at least two numbers, or it can be of two variables. It can be more than two, but there should be at least two. And a mathematical operator between them. For example, 2x plus y. You see this 2 is coefficient, x is variable and y is also a variable, and there is a mathematical operator between them, addition operator. It can be any operator, like subtraction, division, multiplication, any of it. Now let's come to our topic. What is equation? Mathematical statement that has two equal sides separated by equal sign. Equation word leads to a word equate, that means equal. The word itself says there should be an equal sign here. Two expressions, or you can say two variables, or one side expression and another side with a constant, they are separated by an equal sign. That's an equation. Let's come to three other concepts important here. One is variable, coefficient, and a constant. What is variable? A quantity that may change time to time, and it's represented by alphabets from A to Z. Any alphabet, usually we represent it as X, Y, Z or A, B, C. But what does mean by its quantity change time to time? For example, you have an equation here, X plus Y is equal to 10. Okay, now solve this equation. We can put here 9 plus 1 is equal to 10. We can put x is equal to 7 and y is equal to 3. 7 plus 3 is equal to 10. We can put 5 plus 5 is equal to 10. So you see, the values of x and y are continuously changing for an equation. That's why these are called variables. That means a quantity that changes time to time. The next concept is coefficient. What is coefficient? A numerical quantity placed before and multiplying variable in an algebraic expression. What that means? Suppose this is an algebraic expression, 4x plus y, 5. Then a coefficient will be any value that is multiplied by the variable. X is variable here and 4 is multiplied by x. And it's placed before variable. 4 is placed before x, that's why 4 is a coefficient here. But why 5 isn't a coefficient here? Because there is no variable after it and it's not multiplied by any variable. That's why 5 is not a coefficient. But 5 is a constant. What is constant then? A fixed value. Any fixed value, numerical value is a constant. For example, in 9x plus 4 is equal to 36. You see, 4 and 36 are fixed values. They cannot be changed. That's why they are called constants. But why 9 is not a constant here? You see, 9 is coming before a variable and it's multiplied by that variable. That's why 9 is a coefficient. Let's move to another very important concept regarding our topic today, and that's polynomial. What is polynomial? Expression consisting of more than two terms. It can have two terms, it can have more than two terms. But what does term mean here? It means variables and coefficients or constants. And non-negative integer exponents of variables. That means variables should have non-negative integer. And we can say variables should have positive integer exponents. For example, look here, 4x square plus 5 over 4. Here x has 2 power. So that's why x has non-negative integer exponent. you can say positive integer exponent. That's why it's a polynomial. But look in this example. Here x cube is cube 3 is positive. Here x has square over it. 2 is positive. But look over there, divided by x. That becomes x minus 1 and when it goes at top. So that becomes a negative power of a variable. Simply polynomial cannot contain any power that is negative. It should always have a power that is positive. But in this equation, in this expression, the variable is containing the negative part. That's why it's not a polynomial. Move to the next topic or next concept. Here we have degree, the highest power in polynomial expression. Whatever is the highest power in any polynomial expression, that's the degree of that polynomial. Look at here. For example, this is an equation 2x plus 1 is equal to 10. There is only one variable and the power of this variable is 1. So that's the highest power in this equation. So this equation has a degree 1. Any equation that has a degree 1 is called linear equation. Now come to our next point. Our next example, 3x square plus x plus 5 is equal to 4. Here this variable has a power 2. This variable has a power 1. So which power is greater? Obviously 2. That's why the greatest power of equation is its degree. So its degree is 2, and any equation with second degree is called quadratic equation. Okay, look at this equation. This is somewhat different from above equations. Look here, it's 4x square y. There are two variables and they are multiplied by each other. If two variables are multiplied by each other, their powers are added up. So x has 2 power and y has 1. That's why 2 plus 1 becomes 3. So this term has 3 power. This term has 2 power. This term has 1 power. So which one is greater? 3. So degree of the equation is 3. And any equation that has degree 3 is called cubic equation. Same is the case with here. Here the highest power is 4. That's why it has the degree 4. The equation that has degree 4 is called quadratic equation. Okay. The important thing here is linear equation. We are concerned with linear equations. Now we'll define linear equations. Linear equation is an equation that has degree 1. Or you can define it as the equation that gives straight line when plotted on graph. If we plot any linear equation on graph, it will give, let's make it here. It will give us a straight line. So any equation that gives a straight line when plotted on graph is a linear equation. Solving a linear equation means we have to find a value of y when we have the value of x. For example, here x plus y is equal to 7. If we know the value of x, suppose we got the value of x is equal to 4. Then what's the value of y? 7 minus 4 is equal to 3. The value of y is 3. That's why, and the linear equation is solved. In general form, linear equation can be written as, look here, m is coefficient here, x is the variable here, and b is the constant here. If we add these terms, if we solve this term, we get y. So that's the solution of linear equation. Let's move to our next topic, that is system of linear equation. System generally means set of two or more than two things. So system of linear equations means set of two or more linear equations. And that's very simple concept. If there are two or more than two linear equations, we said that this is a system of linear equations. In system of linear equations, we can have single variable equations, two variable equations, and three variable equations, and so on. In a single variable equation, we have single variable to solve. So, such a system of linear equations require only one equation to get the value of its variable. In two variable equations, we have two variables. Suppose x plus y is equal to 7. Here x and y are two variables. To solve two variable equations completely, we need two equations. Likewise, to solve three variable equations completely, we need three equations. Now next come to method to solve systems of linear equations. There are general four methods to solve system of linear equations. First is the graphing method. Here we draw graphs to solve these equations. Next is substitution method. In this method, I'm just generally telling you about these methods. We'll discuss them later in next lectures. In substitution method, we find the value of one variable and put that value in the other equation to find the value of other variable. Next comes a linear combination method, or you can say addition method or elimination method. In this method, we add or subtract the two equations as to eliminate one variable and find the value of other variable. Then put that value in the first equation and solve that equation to get the value of first variable. And other is matrix method. We use matrix in this method. Now come to types of system of linear equations. There are two types: consistent system of equations, inconsistent system of equations. What is consistent system of equations? It is a system of equation that has at least one solution. Any system of equation that has at least one solution or more than one solution to infinite solutions, it is called consistent system of equation. In inconsistent system of equations, it is a system of equation that has no solution. Any system of equation that don't have any solution is called inconsistent system of equation. On a graph, it can be plotted as you can see this graph. This is the graph. The two lines are going parallel to each other. If these lines go on parallel, I told you before, linear equations always form a straight line on the graph. These are two linear equations that are forming straight line, but they are parallel to each other. They never meet each other. That's why if they never intersect each other, they have no solution in common. Then what about consistent system of equation? It is further divided into two types: independent system of equation and dependent system of equations. The system that has single solution, only one solution, is called independent system of equation. In such system of equation, two equations form straight line on the graph like this. They intersect at one single point. So they form one solution set. And it gives single solution. This is called independent system of equations. What about dependent system of equations? It is a system that has infinite solutions. That means if it has infinite solution, that means the two equations meet at many points on the graph. We plot it as, if we make a graph, there will be, this is one equation and the other equation coincided, it's upon it. That means both of the lines, both of the equations meet at each other at many points. That's why they have infinite solutions. System of linear equations can also be divided as homogeneous and non-homogeneous. In term of equation, we say an equation is homogeneous if its constant part is 0. For example, look here, 4x plus 3 is equal to 0. Here the constant part is 0. That's why it's a homogeneous equation. But in this equation, 9x plus 8 is equal to 47. The constant part is not 0. That's why it's a non-homogeneous equation, as the constant part is non-zero. In terms of system of linear equations, if all the equation in system of linear equations have constant part 0, then it is called homogeneous system of linear equation. As in this example, look, both equations have 0 constant parts. But if any of the equation in the system of linear equations have non-zero part. For example, here 3 is non-zero, other equation has the constant part 0, but this equation has its constant part non-zero, then this type of system of linear equations is called non-homogeneous. Now let's discuss homogeneous and non-homogeneous in terms of matrix. Suppose Ax is equal to B. Here A is the coefficient matrix. And why it's coefficient matrix? Because X is a variable matrix and A is multiplied by X and it's placed before X, before the variable matrix. That's why it's called the coefficient matrix. And B is the known vectors of constants. B is constant. So in matrix form, it will be homogeneous matrix if B is a zero vector, and it will be non-homogeneous if B is non-zero vector. Let's pose some examples. Look here, this is the coefficient matrix, this is the variable matrix x, y, z, and here this is a zero vector denoted by O, a bold O. And in this example, this is a coefficient matrix, this is the variable matrix, and this is the non-zero constant vector. That's why it's non-homogeneous. If you like this video, hit the like button below and comment below in case of any query. In next video, we'll explore more about it. Till then, take care, goodbye, tada.